Hello, everyone. How are you all? Yeah. So I'm Ashutosh, and I'm going to cover here uh, the chapter structure of atom chapter for class ninth, and this is a third. This is the third lecture of this whole series of lectures. Okay, for different chapters of various classes like class 9, class 10th. So in this lecture, we are going to learn uh, some new things. Okay, it which will be like in continuation with the previous lecture. So I hope that if you have not watched the previous previous two lectures of structure of atom chapter, so please do watch it before watching this. Okay, so hi. So let's see what are our topics in this lecture and what are we going to cover in this chapter, in this lecture. So first thing which we are going to learn about in this, we are learning about the subatomic particles, how they discovered, and what are the various properties of these subatomic particles, electrons, protons, and neutrons. We already did this, that how electron was discovered, and what are the various characteristics of electron, like mass and charge, and how it was determined. Now in this lecture we are going to learn about discovery of protons, discovery of protons. Okay, we learn about anode rays. Anode rays are very similar to that, like cathode rays. Okay, and then we'll also learn about discovery of neutrons. Okay, and then also you can say we'll know the, you can say, the various uh, properties of all these fundamental particles. Okay, like properties of subatomic particles. Okay, so these are the three topics which we are going to, will try to cover it all in this lecture. Okay, so first let's see. We already know that what was the setup of this cathode rays experiment, and in a similar, okay, on the basis of this cathode ray experiment, a similar arrangement is made. A similar arrangement like cathode rays is, okay, is made, but with, now there's a perforated tube, huh? So like this, if this was cathode, which we know, and this was anode. Now if in place of anode, if we take a plate with holes in it, let's say perforated, huh? like like this, so then we can say that when any particle is going to come like this, so it will pass through it with a positive charge on it or not. Okay, these are also called, yeah, we learn these things. Okay, we can say that this is a modified cathode ray tube. We can say modified cathode ray tube, cathode ray tube. Okay, and these are also called, so the rays coming out of the anode now are positive charge. They are called anode rays. Anode rays. Okay, a similar setup will be there, but with a perforated anode. Perforated anode. Okay, and so now the particles coming out of this perforated anode will have a positive charge on it. Okay, they are called anode rays or canal rays. Anode rays or canal rays. Now what are the various properties of these canal rays? So unlike cathode rays, mass of this positively charged particle depends on the nature of gas, okay, filled inside the cathode ray tube. Okay, in cathode ray experiment, okay, for electron, okay, when cathode rays were there, so it, the nature of cathode ray, that is the mass of cathode ray, the particle of the cathode ray was independent of the gas we filled in this cathode ray tube, while in anode rays the mass of these particles coming out of this anode, okay, as anode rays, is, you can say, is, it depends on the nature of gas present in the cathode ray tube, okay. And these are like positively charged. It comprise of, you can say, positively charged, positive charged, okay, gaseous gaseous ions. So when we take like different gases, so then the nature of these positive charged gaseous ions will be different, okay. And that's how the mass of these particles depends on, you can say, the nature of gas filled inside this cathode ray tube. Next is the charge to mass ratio of these particles depends on the gas. Again, some of the positively charged particles carry a multiple of the fundamental unit of electrical charge. It means that if we fill like some gas, let's say, so then it can also have like two positive, or not like not a single positive, but like positive, like Mg2 positive ion, okay, or Na positive ion. So based on these only, like aluminium will have a +3 ion. So the particles which are coming out from this anode, okay, will have either +1 charge or +2 charge or +3 charge, like this, okay. They can have, you can say, multiple charge, positive charges on, okay, on the particles itself. Now the behavior of these particles in the magnetic and electric field is opposite to that observed for electron or cathode rays. It means since the electron or the cathode ray was negatively charged, and that's why it was behaving like negatively charged particle, okay, in all the experiments. When as you remember that when we took in the previous case the various electric and magnetic field, okay, and when we try to regulate it, then the electron or the particle is going to hit at, okay, B and A and C, okay. This experiment we did, you can refer to the previous lecture. Now here, in case of protons or positive charged these particles, they are going to behave just opposite of that, like negative charged particles, or not, okay. And that's why the behavior of these anode rays is totally opposite to that of cathode rays, okay. And that's why we'll say that these are these anode rays comprise of the positive charged ions, okay. So the smallest positive charged particle which we can obtain from these anode rays is H plus, or not, because hydrogen is the smallest, you can say, lightest positive ion hydrogen will form. And that's why we will say that this is the smallest and lightest positive ion which we are going to get from this positive ion, okay. And that's why it is called a proton. It is called a proton because of this, uh, okay, because hydrogen has one electron and one proton, okay. And since it has lost this one electron, so only one proton is there, so that's why H plus is referred as a proton, okay. It was called proton. This is a positively charged particle, first thing. And then we can say, so the electrical neutrality of an atom is determined, okay, is determined. Then it was observed that the mass of the atom, okay, this proton is, you can say, proton is you can say almost 2000 times heavier than electron, okay. So it means that whatever the mass of an atom has, okay, so proton is responsible for the mass, but electron is not responsible. Okay, because electron is very light as compared to proton. Okay, and that's why it was felt that there should be some other this fundamental particle, okay, also present in an atom. Why? Because proton uh, cannot, like you can say, represent the whole mass of the atom, okay, by its alone. Okay, and that's why there was a it was felt that the presence of some electrically neutral particle should be there, okay, in the atom. Okay, and that's how it was. Then people started doing the experiments, okay, and then uh, Chadwick did one experiment. Okay, what he did was, we can write, Chadwick discovered neutrons, okay, by bombarding a thin sheet of thin beryllium by alpha particles. Okay, alpha particles are, we can say, charged helium atoms, okay, helium ions, alpha particles. So he put like a beryllium sheet, okay, and then he uh, made these alpha particles come and hit these beryllium thin sheet. Okay, so then this electrically neutral neutrons are electrically neutral particles, okay, with a mass slightly greater than that of protons, slightly greater than that of protons. Okay, so are discovered. He named them as neutron because they were neutral. Okay, and that's why this electron, protons, and neutrons are discovered. Now I'm going to write like all the properties of these elements, okay, in a table form. So just to summarize this all, so we can draw a table in which, if let's say we have the subatomic particles, we can write subatomic particles, okay, and we have this electron, then proton, and then neutron. These are the three subatomic particles, okay, and their properties, we can say the symbol is E for electron, P for proton, N for neutron, okay. And after this, so then, like charge, they have absolute charge, the actual amount of charge they have. For electron, we have minus 1.6 into 10 to the power minus 19 coulomb charge, okay. For protons, we will have plus 1.6 into 10 to the power minus 19 coulombs of charge. And for neutron, we'll have zero charge. Okay. Yes. And then we can write further that relatively charged, no? Relative charge. Okay. Relative to each other. So it's like minus 1 unit. We can write minus 1 unit. It will be plus 1 unit. Okay. And this will be zero. Like this, we can write. Okay. Then if we are going to now write the mass in kg, huh? So the mass of an electron is 9.1 into 10 to the power minus 31 kg, okay, while mass of proton is 1.67 into 10 to the power minus 27 kg, and the mass of neutron is also 1.67 into 10 to the power minus 27 kg. Although the mass of a neutron, okay, is, you can say, like heavier, like is more as compared to proton. So if you want to write the, this was the absolute mass, now mass in atomic mass unit, if you want to write, so then we'll call it like 0.00054, okay, is the mass of electron, this much of unit, atomic mass unit. Okay, for proton we can write it 1.00727, and the mass of neutron in atomic mass unit is 1.00867, like this. Okay, so we can write approximately mass, approximate mass, approx mass in U is 0, 1 and 1. And that's what I was saying, that the electrons will have 0 mass, okay, as compared to proton and neutron, and neutrons and protons will have like almost equal mass. And so these are the properties of various subatomic particles. We can write this as a in a summary form, okay, like this. We can write subatomic particles. Okay, so I hope that you understood this whole thing, that uh, about all the three different subatomic particles, that is electrons, protons and neutrons. Okay, we have already seen the discovery and all the properties related to electron in the previous lecture, and in this lecture we covered this discovery of protons and neutrons. Okay, and I explained all the different properties of these fundamental particles, like what are the units of charges they'll have and what are the masses they will have. Okay, if you have any doubt in any of these subatomic particles, in any of these explanations, okay, you can ask it on private forum as well as in public forum. Okay, and then we are going to answer all your queries there. Okay, so this is all for today, okay, for this lecture, you can say. And I hope that you understood all, like everything here, whatever I explained here. Okay, if you have any further queries, you can post it on forum, as I already said. Okay, so this is all for this lecture for today. Okay, and keep learning, keep learning with Ask IITians. Thank you, everybody. Have a nice day.